Good morning, boys and girls. I just had a brainstorm yesterday and decided to put it in action. I put this 7.5-inch 12-volt fan on the charge controller. It's a temporary fit, so how we'll change it, it's just I wanted to see how would it look and kill some time. How I did it, I installed a thermal switch that activates at 35 degrees centigrade. It's about, I think, 92 Fahrenheit, and is attached to the fin of the charge controller, and then it activates the relay. It's a simple 12 volt automotive relay that activates the fan. So once the fin cools off, that deactivates the relay and stops the fan. So it's about 10 o'clock. Temperature on the fin is about 35, so should come on any minute. See how many Fahrenheit is that? About 95. I haven't tested it, so I don't know how is it gonna work out. At the same time, what I did, I shimmed the cover between the cover and the charge controller's case with some washers to give some gap in there so it can suck some more air in, because inside there's some cooling passages. Maybe you can see it right there, that cover that has holes in it. Here are the washers, and give it like a little bit of gap so it can suck more air in. It does have some airflow through those gaps down there where the conduits are, but I thought I'd give it some more to cool off the screen and be able to suck some more air in there. Right now we're at 43 amps, 13.7 volts, 587 watts. The ambient temperature is 71 degrees Fahrenheit, which is coinciding with that one there. Let me check the temperature on the fin again. .8. That's centigrade. It's about 100 degrees Fahrenheit. On this side, 96. So see if that thing will get activated and run the fan. It's a general shot of the setup. I'm not gonna leave it like that. It was just, as I said, a brainstorm I had, and I wanted to see how it works. I had the components, so I thought I'd put them to work, which is that thermal switch that they use in industrial components like air conditioning, heating, or ovens or refrigerators, and just a 12 volt 30 amp relay and some wires. And that's a 7.5 inch, I think it's about 20 centimeters 12 volt fan, which I have one here working to blow air through the inverter, because if the load is not enough on the inverter, the internal fans wouldn't come on, but the components still get a little hot. So that thing helps to have a good flow through the vents in the back. In future, maybe I'll use the other fans that I have. I'll show them to you. The cross flow fans. I got a couple of them, so I may utilize one of them to blow the air through the batteries, and the other one either for the inverter or for the charge controller. We're at 13.5 volts. Array voltage is 58 volts. Let's see what we have here. 43 amps coming in, 13.7 volts going to the batteries to charge them up, 590 watts, 71 degrees Fahrenheit. See what the temperature is on the fins. Plus 95 degrees. How many centigrade? 35. So any moment that should come on. Okay, I'm gonna pause the video and just wait for the fan to come on, and then we start videoing again. Oh, stand by, guys. Okay, here we go. The fan kicked in and is cooling the fins on the charge controller. Let's see. We're at 47, 49 amps, equalizing 14.5 volts. What I'm going to do to test this fan, I'm going to turn the array off so the charge controller would go and sleep, and once the fins cool off, this fan should go off. But before I do that, I'm going to check the temperature. Okay, the temperature on the fin is 37.5 centigrade. Let's check it in Fahrenheit. It's 99.5. Check it again. That's about 99. I guess the fan is cooling it off. Okay, what I'm gonna do, I'm gonna turn the array off so a charge controller will fall asleep, and once the fan cools off the fins, it should go off. Okay, here we go. The amps are dropping. Voltage is dropping. The bottom is the array voltage, is this one. This is the capacitor in the charge controller discharging, and that's the voltage of the battery bank, dropping as well. So we have 0 voltage from array coming, and the charge controller shows 0 amps, and it thinks it's night, and it shows 13.5 volts, which we have the battery bank. Check the temperature. Drop to 94.8 on the heat sink. Okay. Just wait till it cools off and see. That will turn off the signal to the relay, which should turn off the fan. This is the thermo switch that I tightened to the fin of the charge controller via one of the screws that existed already on the fin. I didn't want to drill holes or anything. As I said, this was just brainstorm I had, and I wanted to see how it works. Basically, this is how it looks like. This area here touches the surface, and if it's below 35 degrees centigrade, the circuit internal that connects these two prongs stays open, and once the temperature goes higher than 35 degrees centigrade, it connects the two together, completes the circuit. That sends the signal to the relay. These two are the winding on the relay, and this is normally closed prong, and the center one normally open, and this is the power, and there's a diagram of it. I don't know if you can see it right there. Carry it down to 13.3 volts, 0 amps. Oop, light going off. It thinks it's night. Still 0 voltage from the array. We're running on the batteries. Check the temperature. 90, and it's dropping. Down to 32 centigrade. See how long would it take it to go off. It's basically I brought the wire. Positive is the white, and the negative is the black. That goes into the relay, and one negative goes to the fan, negative side, and the red goes to positive of the fan. And I have a common power going to the thermo switch, and one prong comes to the signal switch that goes to the positive of the fan. Let's see what the temperature is now. .31, and I don't know what temperature this kicks off. I know it says 35, but it comes on at 35, and I don't know what temperature it turns off. It's 30 degrees on this side. The ambient temperature is 26. It's a very quiet fan with high flow. It's made by Cooler Master. It's about 7.5 inches wide. It's about 20 centimeters, and it moves a lot of air and it's quiet. As I mentioned, it's the same I have here on the inverter. That when the inverter is in power saving mode and it turns the fan off, internal fans off, this helps it to cool off and move the hot air through the vents in the back. Right there. See, this fan is still running. I don't know if that thermal switch is stock or defective, but still giving a signal to the fan and the relay to come on. Check the temperature again. We're at 30 degrees centigrade, which is 85 Fahrenheit. But anyways, I'll cut the video short. What will happen once this cools off, the thermal switch, it will cut the current to the relay. That will stop the cooling fan. There you go. But it is still giving voltage. To the relay. I don't know what is the threshold between coming on and off, but I'm gonna turn the array on. There you go. And this is what we have. 52 amps MPPT, 13.5 volts going to the batteries at 700 watts. Okay folks, hope you enjoyed it. Thank you and have a good one. Bye bye.